One of the ways that we're hoping to do this is that for those of you who are already implementing AI in your businesses, this might be a little easier. But for those of you who are not, our goal is that by the end of this tutorial, you would be able to take out a friend for coffee and explain to them what it is that you're doing with AI in your business, why you're doing it, what it is, because there's an awful lot of confusion out there about that. So we're going to kind of walk you through that whole process. Before we do, I want to give you just a brief introduction of who we are, in case you have any questions about it. There are really kind of three main streams of business for us. One is education and training. This is an example of that. Taming dragons is something that we also take into organizations, but now we're doing it in this very big group setting, which is going to be interesting for us. Implementation, obviously, a consultation service that gets machine learning and AI integrated into a company effectively. And then finally, connection, which is finding the right talent to match business needs, which is a big challenge, as you may or may not know. So those are the three kind of aspects of our business. Our overall goal is to just bridge the gap between data science and business. That's what we kind of set out to do. Our founder, who I'll introduce you to in a little bit, Beth Partridge, I'll get to that in just a second. Excuse me. So we've done the show of hands. Here's what we're going to accomplish today. The first thing is that we're going to provide some clarity on what AI is in business and how it is that you can use it. So for those of you who are already using it, hopefully we can expand your thinking about how you might implement it further. We're also going to provide you with the seeds of a plan, basically a plan to get AI implemented throughout your business. It's an opportunity assessment that's going to be kind of the organizing principle for our time together today. It's really gonna be organized around something that you'll find in your packet. On the right side of your packet, you will find at the back this organization chart. It's a little bit more blown out. You don't have to get it out yet, but you'll get to it. And the point that we want to make here is that we're just not talking about what AI is. We're trying to find the best possible ways to implement it into your business. So there's going to be some hard thinking as we go through some exercises to kind of find a way to get all of this onto this page so that you can walk out of here with the seeds of a plan. And then finally, we want to get you to prepare to launch. So some of you are obviously already launched, but there's a process that we believe is fundamental to implementing AI in a very successful way in a business. There are a million ways to really screw it up, and we want to make sure that we're kind of looking at this in a way that makes the most sense for you. Okay? I want to make a couple of just housekeeping announcements. We have parking lots stationed over here on this wall. We're going to be going through an awful lot of information, and our goal, obviously, is to answer each and every one of your questions, but we would like to be able to kind of get through this. And we're going to, if you have questions in the process and you want to make sure that you're capturing them, if you could use any of the Post-it notes that are scattered on the table to get those questions up there. During the breaks, we're going to go over there and consolidate all that information and address it directly. We'll also have a Q&A section at the end. And of course, any questions that you have for us afterwards, please just come to us afterwards or bring us a note or whatever it is, and we'll make sure that we get it addressed. So that's kind of the approach that we're going to take with this. I'm going to turn it over to Beth now. So I want to give you a little bit of a plan here, or a little bit of a break description of Beth. And I don't know, oh, sorry, where'd it go? Okay. So Beth has 30 years of experience as a business executive on the technology side and the engineering side. She spent a great deal of that time at Intel, running factories, getting factories up and running. She can speak to a lot of that. She also launched she was part of a boutique technology consulting firm for a long time. And then she went and got her her MA in data science at Berkeley. And when she came out of that, the big realization for her was that implementation of AI technologies is essentially stalled in business. This was the big takeaway. So she didn't want to go into any of the big data native companies and kind of take off and go that way. She was more interested in helping as many companies as possible get implemented with this technology because it's going to change the world, much less business. So that's kind of the orientation. That's where we came from. That's where Milk and Honey came from. And we'd be happy to share that more. But I wanted to give you that as a setup for Beth, who's going to do most of the heavy lifting in this presentation. I'm going to be helping you do some exercises along the way. So I'll kind of MC this a little bit. But Beth is going to be doing a lot of the big lifting. All right?
Thank you. Hi, everybody. So can't really start a discussion about AI without first doing a level set on terminology. And I think it's important with any terminology transition, but I think there's been, this one has had more of its share of confusion than any other. And I think we've probably all read a million different versions of the definitions. I think for a while you couldn't, crack an article without that being the first thing they said. But they kind of go in one ear and out the other. They don't really stick. They're not really useful. So I'm going to try and come at this in a little bit of a different way in hopes of giving you hopefully some clarity right off the bat. So the way that all of this technology that we're talking about today, its first incarnation was really as big data. And it was actually our host, O'Reilly, that coined that term back in 2005. It hit Gartner's hype cycle for emerging technologies in 2011, and a couple years later, it just kind of disappeared, because it really did follow the quintessential hype cycle where all these companies ran out and had their big data mined for, all this amazing stuff, but there was no real business goal associated with it. So no business value came out of it. So essentially, big data got a bad name and kind of dropped off. And so, but there was definitely something there. And so it emerged under machine learning, more or less. And just as we were all kind of trying to get used to what machine learning meant, there was a breakthrough in a kind of machine learning called deep learning, which enabled machines to effectively see and hear and speak for the first time. And of course, this made us all think of robots and artificial intelligence, which was a term that was much more familiar to us. And so the industry kind of, morphed over into artificial intelligence where we are today. So the good news is that from a business leader's perspective, I mean, there's different definitions for all these things, and you could dig into them about the differences. But from a business leader's perspective, all of these things are referring to the same thing. So machine learning is what you do to big data, and artificial intelligence is what you get out of it, but really all the same thing. Another way to think of it is if big data would be like fuel, if machine learning is like an engine. But so here's another reason why there's some confusion, is that if you didn't know about cars and boats and all those things that we can put engines in, if we told you that you get mechanical power from fuel and an engine, it wouldn't really be meaningful to you. And neither is artificial intelligence at that form. So a lot of what we're going to do here is define that, take that to the next level so that you guys understand how you harness artificial intelligence and use it in your business. Okay, so let's start with, there's really 3 ways that companies can utilize AI. The first one is companies can sell AI-related technologies that enable other companies to use it. And like the 2 biggies are Amazon Web Services, of course, is the premier cloud platform for data science. Google Cloud is coming up right behind it. The second, this is just a couple of examples. The second way that companies can utilize AI is they can sell AI-driven products and services. And some of the big well-known ones are, at the top there, Amazon's playing in this space with their Echo. Google's initial foray was, of course, the AI-driven search, which really was the foundation and where all of this technology that data science is based on was developed. And then there's Facebook and Apple, who have AI-driven products. And then the third way that companies can use AI is to drive their business. And if you think about it, Amazon's real claim to fame is their recommendation engine. And if you think about it, they're not really selling, the things they sell aren't AI-driven. It's the way that they're offering them to us that's AI. And same thing with Netflix. The movies that we consume, the actual products are not. So first, just a little tidbit that these companies that are represented on the screen here, Facebook, Apple, Amazon, Netflix, and Google, they're commonly referred to as the data natives, and the FANG. That's the acronym FANG that the financial community has given these guys. That's these 5. Just a little tidbit. So even though Apple, Google, and Facebook don't show up, or they're not known for the things that they do to run their business, you can bet your ass, and we know personally that they're using it to run their business. Because once you understand the power of machine learning, you don't do anything without it. In fact, it's kind of a cover your butt thing in these companies, where if you do something and you screw up something and you didn't do machine learning, it's like, you're like known, the laughing stock. So what we're going to focus on today, of course, is using AI to run your business. And we collectively refer to those as enterprise AI. And there are 2 main categories of applications of AI for business. First, there is a next generation of automation opportunities, and there's a skip generation opportunities in analytics. Okay, so we're going to start first with the automation capabilities. So first a note, just a little definition. We're defining automation applications as those that are designed to perform a repetitive task that previously could only be performed by a human, in this case. So in a nutshell, what the next generation of automation capabilities is that we've effectively broken through the barrier between the natural and digital worlds. And machines are now able to interact in our natural world in much of the same ways that humans do. They can speak, they can talk, they can even move around autonomously. So let's take a look at what some examples of what that means to business. So the automation applications we all usually think of, assembly lines and, mechanical kind of stuff. And this really takes it completely out of that realm. So some examples for vision, where currently, we've had some capabilities that maybe, looked at colors of fruit down the line, or, maybe did some mechanical stuff. That's still in the analog world. But now computers can actually see and interpret and identify things in the images. So we can do things like video security, including, recognizing faces, recognizing activities, all kinds of different things. We can do, obviously, objects and IDs or people and places in pictures. And one of the more better known applications is, of course, in radiology, where machine learning models look at a picture, an image pixel by pixel. So they can see anomalies that the human eye can't see, it can't even come close to seeing. So that's some examples for vision. For speech, of course, we've had like voice call trees where, supposedly they could understand, one word, but they were really, just trying to look at signals like waves and try and recognize them. But now we've gotten to the point where they not only can recognize the wave, but translate that, understand it, and then spit it back out in real language as well, which is, of course, chatbots, which is one of the applications that's getting good traction. We can do things now like our AI can transcribe videos. So if you have videos on your website, you can automatically have it transcribed so it's searchable. And then we can do things like voice ID. Language is another big area where it's having an impact in business. The previous generation was limited to things like OCR, where you could convert faxes or whatever into text. But now, of course, everybody's seen or heard of the earbuds. Who would have thought we'd have a commodity product that's like a couple $100 that could do real live translation when you're talking to somebody? I think it's just astounding. And that's really just the beginning. We're doing things like sentiment analysis of tweets for you guys to keep track of, how your products are being, embraced. And then finally, there's the traditional robotics, and the robotics have gotten a boost from these other things. So now that machines are able to see and speak and interpret the world around them, they're no longer tethered like they used to be to, stationary. They can actually move around autonomously in the area. And of course, that's leading to, autonomous transportation and that kind of stuff. So I think now we're going to let Byron walk you through some exercises just to kind of get your head around how you might start to identify opportunities to implement automation in your business.
Okay. So I want to start with a quick story. Early 1990s, I was the general manager of a small magazine in the Rocky Mountains, and Wired magazine had just come out. And there was some pretty crazy stuff in there for people who were in business. And I read a story in there that in the not too distant future, people would buy things on the internet. And I just remember laughing, thinking, who is going to put their credit card into that black box? What's going to happen with that? That just wasn't that very long ago. I bring it up because we want to set you up a little bit here, because we're going to put you through some what could be some difficult exercises, especially to start. And what we want to encourage you to do is really just imagine the impossible. So if you have your own moments where you think that something is just laughably impossible or really dumb or any other kinds of things, those things could actually be transformational for your business and others. So we want to really get you to open up as much as possible. The best ideas, as Einstein said and many others said, often sound absurd at first. This kind of technology is the perfect opportunity to think absurd thoughts and just kind of capture them. Don't worry if they're right or they're wrong, just kind of go with what they could be based on what it is that you really want to accomplish. So this isn't really about, the goal is really to just free yourself from a lot of the decision-making processes that you're in every day. I mean, we all go to work every day and we make this series of decisions, and we often make them over and over and over again. Imagine if a lot of those decisions could be replaced with just tremendous data and information, and you could just go from there. You would be free to think of other bigger questions that have more impact on your business. So we're trying to get you into that space, and we're hoping that you can just suspend disbelief and just go with crazy ideas. We're going to take you through these exercises individually, and then we're going to pull you together at one point so that you can share what it is that you're coming out with. Because there could be somebody sitting right next to you that has an idea that really resonates in your company that just didn't occur to you while you were doing this. Okay? So we're going to go into the first exercises, and they're about automation. Oh, sorry, I didn't click through those things. So I want to start with my glasses. We've broken automation into the three things that Beth just talked about. We've got imagery, and we've got audio, and we've got language. What we want to do is just imagine if you could identify something specific in photographs or illustrations or video or any other source of visual data that is available to you, what do you think you could do with that data? An example in kind of in a statement form that we're going to walk you through is if you could identify, in this case, a candidate's facial expressions for a job, you could better evaluate his or her interest in that job. This technology is available right now. It may or may not make sense for you to use it, but it's frankly revolutionary. That just didn't exist all that long ago. So these kinds of things are going to find their way into business. So if you open your folders, on the right-hand side, you'll see a small packet that starts out with automation, an automation exercise, right? We're going to give you a minute to think about this just individually, and you'll see this following statement. If you could identify blank in blank, you could blank. So there are some hints to kind of keep in mind here. Sources could include anything from social media to surveillance footage to product service related image capture. These are just a few. You might have other ideas based on the businesses that you're already in, but we want you to kind of fill in these blanks. We're going to go back and put these examples up in front of you here, and I want to point out that at the very back of that packet of exercises that you have, there are a few other examples that are stated a little bit differently, might resonate more with you. But try to take a few minutes and just think in your own context of business what it is that you might be able to do with that sentence, okay? And we'll just time you, and then we'll stop you, and we'll go on. Okay, let's move on, all right? You're going to get a chance to talk about these and think about these with your others. But right now, we're just trying to get a series of possible applications for AI in the automation space captured. Okay? So the next one is going to be audio. If you could recognize something specific in live or recorded audio sources, what could you do with that data? And the example that we came up with is if you could recognize a customer's emotional state in his or her tone of voice, you could customize your response to that customer. Again, this is happening in some places. It's pretty new. A lot of people aren't really implementing it. It might occur to many of you right away if you have a strong customer service connection with your audience. Then you might find this to be extremely helpful. Others might struggle with this. But again, the sentence that we want you to try to fill is: if you could recognize blank in blank, you could blank. Right? So audio sources could include data that you capture, customer service interactions, as well as data that you consume, podcasts or any other thing that you think of. So the second sheet in your packet is about that, and we'll give you 2 to 3 minutes. All right? The next and last one for automation, I promise, is language. If you could interpret something in the language that you generate and consume, what could you do with that data? So for example, if you could interpret sentiment in the claims forms that you process, you could minimize settlement payouts. Obviously, this is going to apply to anyone who is in here in insurance, but it could apply something like it could apply in many other ways. The question that you're filling out is on page 3 in that, and it says, if you could interpret blank in blank, you could blank. Consider focusing on one source, something your company or your customers, competitors, or outside content producers produce. Maybe that'll help you kind of focus in on what it is that you could do, with something that's coming to you that you could then kind of do more with than you're currently able to do. And I'll put those examples back up with a brief reminder that all of this is going to work its way into that org chart that we set up at the beginning. We're going to move on now. Beth's going to take us to the next stage.
Okay. So as thrilling as some of the automation capabilities can be, they're more obvious. The applications of them are more obvious, and frankly, what you get out of them is more of a one-time productivity bonus, and the benefits of it pale in comparison to the skip generation of analytics, and that's what we're going to spend the whole rest of this time talking about. So, what do we mean by skip generation analytics? So it's actually a really good question, because many of the same approaches and algorithms are used in the previous generation of analytics as in this generation, and there's actually confusion and dissension within the analytics community of what's the difference between a statistician and a data scientist. And there's actually been some confusion where statisticians have labeled themselves data scientists. And anyways, so I'm going to go through the difference between traditional statistics and machine learning-based analytics, first from a perspective of how they work, and then I'm going to use a specific kind of model to demonstrate the big difference in the power and what you get out of them. So first, this is just a graphic of a standard statistical model, and the way that it would work is that you would take a sample of data, put it through an algorithm, develop a statistical model like a regression model, and then you take, whenever you have new data, and then you get the prediction out. So what changes when we switch into the machine learning and the big data era is that, of course, the data changes, the amount of data changes. And just by virtue of the sheer volume of data, you're forced to move into a distributed computing environment because you can't handle the volume, or it's not practical to handle that volume. And so that, by definition, takes you into machine learning. So, of course, machine learning models learn, so there's always this feedback loop where you're feeding back in how accurate it was. But even after a model reaches its desired accuracy, you can't stop maintaining machine learning models, because when they're, you're talking about accuracies at in the upper 90, 91, 92, 98%. When you're with old models where you had a plus or minus 2 or 4, whatever, you weren't sensitive to changes in the environment. But when you get into a machine learning environment, you are sensitive to very subtle shifts. And the best example of this is, remember the Google flu application that came out in the 2009, 2010, and it made headlines because it was able to predict the spread of flu 14 days ahead of the CDC, and it was actually, helping them get vaccines ahead of time, and it had all this great benefit. Well, after the hubbub died down, they stopped maintaining the model. And so 2 years later, it made headlines again, but this time because it was wrong, and it was predicting that, it was going to the wrong places, and they were sending medication and all the thing. So it's just confirmation that they just can't sit here. So there's this constant need for an intensive compute environment. So that's technically how they're different. And now we're going to use one of the algorithms that's common between the traditional statistics and the machine learning statistics to contrast how what you get out of them is different. So just a quick refresher for people that haven't been doing statistics, haven't been living it like some of the other ones are. This is a simple regression model. And the way that it would have been developed is a scientist would have taken a sample of people, measured, this particular one predicts somebody's height from the length of their femur. So the way that it would have been developed is a scientist would take a sample, measure the femur, measure the height, plot it on this graph where the femur length is along the x-axis and the height is along the y, and then they would draw a line through those points, and then that formula becomes the model that they would use. So when they find a new body or whatever it happens to be, let's say it's a femur that's a 16-inch length, they'd go to 16 on the bottom and follow it up to that line, and that would be the answer, right? So the problem is, in fact, if you look at 16, if that person, or the data point that you can see that where the 16 is actually below the line, that represents an error. So this model is not as accurate as it could be. So the way that you try to minimize errors in models is you look into the error points and try and figure out what's different. And in this case, if you dig into the data, it becomes obvious that there is different behavior between males and females. So if you divide those samples out and treat the males and females differently, you can see that the errors come in a little bit. So each of the populations has its own distinct model, and they're a little bit more accurate for those characteristics. And if you do it again and recognize that there's differences in the origin. In this case, you divide female, African, Asian, and European descent. Now you can see you get where the models are very, very accurate. And this is, of course, an anatomical case where there are very few variables and it's not very dynamic. It can get to this kind of accuracy. So the whole point, really, that I want you to take away is that that the way we approach improving models to reduce the error is by recognizing when there are distinct populations within the sample and then giving them their own distinct models. And then when you add them all together, their error is less, okay? Okay, so now let's take that into a business environment and say that this is now a regression model where you're predicting sales. So if you think about it in this case, the white line is the projection. So if you came in under projection, like where the red dot is, that represents you having come in under the projected sales. And of course, that results in excess inventory that you have to dump and all kinds of business loss. On the other side, if you come in above what was forecasted, well, you got a little bit of extra sale, but you don't even really know how much higher it would have been unless you built up a bunch of extra stock, right? So the point is that when errors like this in the real world, they mean something. I mean, if the scale along that the left line is billions, that's a lot of dollars, right? And so, of course, we in business routinely use customer segmentation models in the same way that we just talked about with the bone models, where we try to identify the distinct populations and treat them differently. So let's say that model was using, that particular one used a 4-segment model. Then it stands to reason that if we segmented further, found more unique ones, it would bring the error in. As you can see, it probably would. And you could continue along that vector, and it would expect the error to continue coming in as you recognize more and more distinct populations. The only problem is it costs money to do this sampling and testing. So it gets to a point where it's prohibitive, or you could spend more doing the sampling and the testing and the projection than you stand to make on the project in the first place. So you end up, you get to a point where it's prohibitive. And so for all intents and purposes, we're stuck in the current generation of analytics at the one before it. And so that's why you see us doing all kinds of things to do for like just-in-time manufacturing, and we do all kinds of things to try to minimize the financial impact of that. But we just can't, just not from practical purposes, we can't get any better than that. Okay, so what's changed? So now we're in this hyper-connected world where we could feasibly now probably do near 100% sampling, right? I mean, when we first developed those other sampling methodologies, we just couldn't reach everybody. We didn't have any choice, and we were super happy that sampling worked, right? It was awesome. But so we could, for all intents and purposes, do that now. But the fact is we have massive amounts of data on each person, so much so that we don't even have to ask them in order to very accurately predict their behavior. So if you put that back in the context of what we were just talking about, now we've gone from being stuck with some error that we try to minimize, and now we've effectively gone to where we have segments of one, and we don't even have to ask them, using data we already have on hand. Does that make sense? So let's look at what the impact of that is. So in the previous paradigm, we have forecasts that maybe they're by region and maybe by product, but we're always doing adjustments and moving them around, and we just, like we said, we live with it, right? Well, in this new paradigm, when you get to an accurate model, you can not only predict accurately how many things you need to buy, but if you think about it, we also know from the data about our customers, we know when they're going to buy it and we know where they're going to buy it. So now instead of just making the right amount, we're making the right amount at the right time and shipping it to the right places. So already it's a significant difference, right? You're totally optimizing maximizing the potential of what you got. But that's not the end of it. When you have a model in place like that, you can use the model. You can use the model to gain insights into why certain things happen. So let's say there was the same product in 3 different colors, and 2 of them sold out and 1 didn't. Well, now all these people that used to spend all their time making production adjustments and moving stuff around potentially, can be looking for insights in this data. And let's say they found that, one of the products was a different fabric or whatever, and it didn't sell. And so they can go and tell the product development folks, hey, guys, this didn't sell because of this. And they go, oh, or maybe it's, two cities that normally sell out the same, and one didn't for some reason, and they dig into it and figure out there was a promotion at one, so that the price was a little, anyways, they can go tell the marketing folks, right? So you're getting insights now that when executed, they end up not just optimizing the pie, but growing the pie. And then we're still not done there, because again, once you have that model in place, you effectively have a simulator that you can use to validate. And we're not limited. I mean, they could validate and the suggestions that those folks made, and see what would have happened if they'd used the different fabric, or run that. But they can also simulate things that are even completely out of their control. For instance, you could simulate what would happen if my competitor lowered their price. What would the impact be on the total sales? Is that clear? So that's a sales example, and I use that because we're all used to it, and the concept of segmentation makes sense. But now let's look at a model in the area of HR. So HR departments have to forecast what they think their attrition is going to be. So it costs a lot. I mean, there's a productivity hit, and it costs a lot to be hiring people. So today they might use historical averages, or their own averages or historical averages, to project what it might be. But if they can build a model that projects how long or how many more months until each of their employee leaves, not only will they know how many, not only can they forecast better, but they know which ones. And so they can actually take actions to head it off. So again, instead of just maximizing your efforts and being more accurate, you're actually able to increase the amount of value. And then similarly, once you have that simulator, you could do things like simulate what would happen if you cut back on healthcare benefits, or, whatever. You have a way to evaluate by varying any of the parameters that feed into that model. And then the third example is yet another completely different area, and this is one that's getting popular, is in preventative maintenance. So the practice today is to do periodic maintenance, and really conservative, because the lines down situations are so expensive that we err on the side of being cautious. But if you can create a model that will accurately predict how many more hours till each of the pieces of equipment failed, you can not only stop doing the preventative maintenance altogether, but you effectively eliminate lines down at the same time. And this one has even more impact for your ability to drive improvements, because you weren't even letting your machines run to the limit. So you just had no idea how much further they would have gone. But now that you're able to let them run further, you have data to see what's different about the machines. So you can dig in and find insights and figure out ways to make the machines overall run better. And then similarly, you could use it to run different scenarios of whatever impacts it. So this is why we call it skip generation analytics. And these are just 3 examples from 3 completely different parts of your business, and it can apply anywhere throughout your business. And we really, the impact of machine learning to analytics is as profound as something like the telescope for astronomy or the microscope for biology. It completely changes the game. When you go from settling for averages where you don't know anything about the individuals to knowing, it just opens up all kinds of new possibilities. Is that clear? Okay. So I think we're going to take a break. 15 minutes, Helen?